I mean, just obviously we can improvise about what we want to talk about with this topic, but I thought that just at the beginning, it might be handy if I just talked about the anatomy situation, the neurology situation, just a little bit, just to make sure that we are on the same page. Does that sound okay?
That sounds excellent.
Okay. Yeah, so we're talking about bivalves and sentience, of course. When people claim that oysters and clams and other bivalves are non-sentient, I noticed that one thing they often do is assert that as a fact without any evidence, often using the word if. If they're not sentient, then it's fine to kill them, which is an assertion of fact hiding behind a conditional phrase, because people are actually claiming that they're not sentient, but without actually standing behind that and giving evidence. And it's an assertion which they haven't supported. Or, alternatively, when people make that claim and they do try to support it with evidence, they get the science wrong. And that includes people sometimes using quite a lot of scientific terminology, which can give the impression that they know what they're talking about, but in fact they don't. The most convincing argument I've ever heard against bivalve sentience was something I heard on an old comment thread the other day. And every other word this person used was straight out of a biology textbook. I mean, I'm a PhD, but I try not to use technical language, more than is necessary, because there's no point. But this person was talking in an incredibly technical manner, and yet the actual claim they were making, factual assertion they made, to do with the cerebral ganglion was completely wrong. So, you've got to be very careful when you're dealing with this topic, if you're not well versed in it, that people can sound like they know what they're talking about, and in fact they don't. So, just trying to remember what the person said. It was, it's to do with the cerebral ganglion. So, anyway, I went and looked up the actual definition, the dictionary definition of the word brain the other day, which I'd never done before, funnily enough, but I just thought I'd try it. And the Oxford English Dictionary definition of the word brain is, I've got it written down, it's the convoluted mass of nervous substance, in other words, neurons, etc., which is contained in the skull. And of course that definition works fine for human beings and other mammals and for birds and for fish, but what happens when you've got a brain which doesn't have a skull around it? Well, it's still a brain, but the word brain no longer gets used for it. And that's the situation we've got with bivalves. They've got a brain. Every bivalve has got an anatomical feature, which is a brain, a big bunch of neurons which controls things. It does everything that a brain does, sending out signals, getting back signals, making decisions. But it doesn't get the label brain. It gets called a cerebral ganglion. It's a very particular ganglion. It's not like the other ganglia that bivalves have got. It's the cerebral ganglion. And the only reason why it's called a cerebral ganglion rather than a brain is that it's in the body. The anatomy is such that the brain is in the body, so it doesn't get called a brain. If it had a skull around it, then it would be called a brain. So when people say, and I'm sure you've come across this, people say bivalves don't have brains or oysters don't have brains, it's very misleading because it implies that they're like a human being or a dog or a mouse with the head amputated. It's like a headless person walking around. But or that they're a headless, brainless version of an animal, and it's not a proper animal. That's just not true. They've got a skull-less brain, a non-cephalic brain, consisting of neurons, just like any other brain, and it's called a cerebral ganglion, or sometimes it's known as a cerebro-pleural ganglion, which is when it's combined with the pleural ganglion, which supplies nerves to the mantle cavity. But cerebral ganglion is the underlying term. And I mean, do you know what the word cerebral means? Have you come across it very much yourself?
I have not. And may I jot in and just mention, from a
Yeah,
vegan's point of view, like
yeah,
vegans who hold that position clearly are not vegan. That's a
yeah.
species point of view to to discriminate based on a lack of features on another species just because they're not like us. therefore justify, rights violations towards that species. So clearly, not a pro animal rights position. That's all I want to mention.
Yeah, yeah, I absolutely agree, because obviously we happen to have a brain with a skull around it. So what's happened is that we've sort of loaded the dice in our own favour. We've sort of made it a rule that creatures have got to be as much like human beings as possible in order for us to care about them. But yeah, the cerebral ganglion basically means the brain ganglion. The word cerebral means brain. So yeah, and so it's different from a pedal ganglion, which operates the foot. It's not the visceral ganglion, which is to do with digestion. It's the cerebral ganglion, the brain ganglion, and it's the bit that's the brain. It does what a brain does, and it's made out of neurons, just like a human brain is made out of neurons. And it's got the job of connecting up the other bits, and it makes the decisions and all the rest of it. And it just happens not to have a skull around it, unlike human beings and mammals, etc. And so following on from that, there's then a lot of misunderstanding which people tend to have also about the central nervous system. I'm sure you've heard mentioned in relation to bivalves, because the word central in the expression central nervous system refers to the part of a nervous system which runs down the middle of the animal, as distinct from the peripheral nervous system, which goes out into the limbs. So in most animals, including mammals, you've got a central nervous system consisting of a brain and a spinal column running down the center, and then the peripheral nervous system is in the limbs. And so a central nervous system just is running down the center of a symmetrical animal. But of course, bivalves aren't symmetrical like that. They haven't got a limb on each side at the top and the bottom like we have. Everything is just configured differently, and the brain is built into the structure. The brain equivalent, the cerebral ganglion, is built into the body, but it does the same job. Because of that, because it doesn't have what we would normally call a brain, people then say, well, they don't have a central nervous system because there's no head and no spine. But the components of a central nervous system, the actual things which make up a central nervous system, a command center, a brain, aka cerebral ganglion, which then links up to the rest of the nervous system, that's all still present. And bivalves still respond to painful stimuli and so on. And some scientists even refer to bivalve cerebral ganglia as CNS ganglia, central nervous system ganglia. They actually use the term sometimes, central nervous system, in relation to bivalves, because that is the function which it's performing. And I was in fact just reading some scientific research today about oysters responding to pain. I'm going to have to read it in more detail, but it's obvious what it's saying already. And that is all based around obviously the neurology, and that's how they feel pain, that's how they respond to pain, that's how they behave, that's how they experience the world. They've got these senses, they've got the brain matter, the neurons. It's all present, it's all there, just isn't in the same shape as the sort of animals that we're used to thinking about, like dogs and cats, and of course the human animal. So the idea that they don't have a central nervous system, if somebody ever says that, then that's actually as meaningless as saying they don't have a brain, because it's just anthropocentrism again, as you were saying. It's they're not a human being that's been born without a head and is therefore incapable of experiencing anything, because a human being without a head wouldn't be able to experience anything, because our consciousness is inside our skull. They're not like that. They're a non-human animal which has got a neurology which is essentially the same as for every other animal, but just in a different shape. So ultimately it's all about the neurons, and whether the neurons are inside a skull or outside a skull. And another interesting example, if I can just talk a little bit longer just about this before...
Of course, as long as you need.
Yeah. Thanks. Another interesting example is that of lobsters, and I know that I've talked to you a little bit about that before. The British government is no friend of non-human animals, like most governments. It subsidises animal agriculture and animal experiments, etc. But even the British government has now officially recognised, from 2021 onwards, having commissioned their own in-depth scientific research, that crabs and lobsters are sentient. And yet the interesting thing about lobsters is, guess what? They haven't got quote-unquote brains. They've got cerebral ganglia instead. And lobsters have got heads, but there's no brain inside them. The brain, aka cerebral ganglion, is outside the skull. It's still there in the same way that it's still there with oysters and clams, but it's not inside the skull. And yet, lobsters are sentient, and that's not an animal rights position, that's a government position. And brains are not needed for sentience, just cerebral neurons operating as a brain, which brings in the signals and perceives things, and, that's the sort of central processing unit. That's still there. It just doesn't get called a brain. And so people get very hung up on that. They think, they're a headless animal. And that's not the whole story. And have you ever looked into the starfish example, by the way? Because that's another interesting one.
No, I would love to hear about your
Yeah.
deductive reasoning also on that.
Okay, cool. Yeah, well, I don't know a huge amount about starfish, aka sea stars. Do you call them sea stars where you're?
I think people just, it's a preference thing.
Maybe it's.
It doesn't
Yeah.
matter to me.
We tend to call them starfish. But yeah, they're if you ever look up some YouTube videos of starfish, doing their thing in the sea, they're ruthlessly efficient predators. They're heavy duty. They're very capable when it comes to hunting other creatures, which isn't very nice, of course, but that's what they do. And yet, guess what? They don't have a head. They don't have a brain. And they've got a different system from lobsters and from bivalves. But again, there's no brain. They've just got the neurons. So, once again, it doesn't matter whether there's a head or a quote-unquote brain. All that matters is that there are neurons which perform the function of a brain, which act as a brain. So, those are sort of two of the really, really fundamental things which I've come across so often in relation to this discussion about bivalves, is that people talk about no brain in a very misleading way, or they've sort of misled themselves because they assume that there's no sentience if there's no quote-unquote brain, or you talk about central nervous system without looking at whether the components are actually there, which they are. And then another major error, which ties into these, is that people tend to refer to the ganglia of bivalves, including the cerebral ganglia, which is their brain, as nerve ganglia, which I'm sure you've heard. And that's very misleading, because it's not just nerves like we would have on the end of our finger, sensory nerves that pick up pain, like if you prick your finger. It's also nerves in the sense of neurons and brain matter. So they do have non-brain ganglia, in other words, non-cerebral ganglia, such as the visceral ganglion, which I've already mentioned. And human beings have got neurons in their gut as well to help our gut contract at the right times, etc. But those neurons are specialized. They're tied to a specific little task. They're not control centers like a brain or a cerebral ganglia. And strictly speaking, cerebral ganglia shouldn't necessarily be called ganglia, because ganglia normally means neurons in the peripheral nervous system, which doesn't apply with bivalves, because their cerebral ganglion is in fact acting as a brain, which is a central nervous system feature, not a peripheral nervous system feature. Which is why some scientists speak of bivalve central nervous system ganglia. They use the word central nervous system in relation to it. But for most of us, the language just trips us up, because it's all designed to describe human beings and other cephalous animals. It's speciesist, as you mentioned. And the language very often falls apart when it's called upon to describe oysters or lobsters, because the terminology which we're using wasn't designed to describe those branches of the animal kingdom. I've got a couple of other little anatomy points I'd like to cover. Is that okay?
Absolutely.
Yeah, cool. So, so again, when people say bivalves don't have brains, they've just got nerve ganglia, as if an oyster has got nerves, like a finger has got nerves, but no brain to connect those nerves to, they're doubly wrong, because one of those ganglia is a non-cephalous brain, a brain outside a skull, and they're also gone wrong because bivalves have got neurons, not just sensory nerves. So it's this kind of misunderstanding which leads people to jump into these false comparisons, which I'm sure you've come across. For example, like they'll say bivalve is comparable to a severed finger because there's nerves and no brain. Well, no, it isn't. It isn't comparable to that at all because, yes, bivalves have got sensory nerves, the same as human beings have got sensory nerves, but they've also got a control center, which a severed finger doesn't have. They don't have a cerebral ganglion acting as a control unit. And if they did, is the really funny thing, if they did, then a severed finger would, if it had a blood supply and could survive, it would be able to, make its way around and detect danger and hide from danger and dig under stuff and get into fights with other severed fingers, like bivalves sometimes get into fights with other bivalves. And the severed finger obviously can't do any of these things because it doesn't have a central processing unit. It doesn't have any version of a brain. So when people sort of use the severed finger example, they're just kind of proving that bivalves are different from that because you've only got to look at the behavioural stuff and at the neurology in detail, and you see these big differences. You had a discussion about the severed finger thing, didn't you?
I sure did, and
Yeah,
that was a dumb
yeah,
conversation. If I'm being honest with myself, I was like,
yeah,
well, clearly the severed finger it cannot detect and attempt to run away. Of course, it would just respond to like, you press, making intelligent actions onto the nerves itself, but it doesn't actually like
yeah.
attempt to survive itself.
Yeah, and obviously it's being controlled by your brain, isn't it? It's
Yeah,
not being controlled, it's not doing its own thing. It's not wandering around living its own life.
yeah,
Even if it could, even if it had a blood supply, it wouldn't have that autonomy. It wouldn't, it's not an animal, basically,
yeah.
is the point.
It's
Yeah.
just it is literally just simply a cluster of cells of nerves. I mean, like nerve cell,
Yeah.
nerve. Yeah. Um.
Yeah. 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 And I mean, you can have reflex actions with some parts of the body, like when if you tap your knee just below your knee and you can get your leg to flick out, that.
Yeah, that's the type of
Yeah,
reaction that a severed finger
yeah,
would only be able to do. It won't be able to detect danger, run away from its perceived
yeah,
predators, etc. It just literally
yeah,
reacts in an intelligent way to its negative stimuli interactions. So, you
yeah,
press,
yeah,
interacting with the nerves itself, yeah, they will react in an intelligent way to what, but not in a way to have to perceive to run away because they can't do that.
yeah. And an interesting thing about reflex actions is that the reflex action that I just mentioned to do with your knee, if you tap below your knee and your leg shoots out, that takes around 3 or 4 neurons in order to accomplish it. It's
Very
it's
interesting.
motor neurons. Whereas if you add up the number of neurons which bivalves have got, it's in the thousands.
Yeah,
It's
they got
six or seven.
at least
Yeah,
let me just yeah, it was around 6,000 approximately.
yeah, yeah. I know it's somewhere between 6 and 7,000.
Wow, so they had
And
that wrong entirely. I couldn't name those people, but I mean, it's up
yeah,
to
okay,
you. We can just leave them out, but I'll definitely, I don't know. I'll try to if I'm able to get in contact, I'll definitely reference this conversation for them to look at if they want to actually debate this in the future. But obviously, it's not
yeah, sure.
looking that's not looking to happen anytime soon.
Oh, okay, yeah, yeah. One of the interesting things about the different sets of neurons within bivalves, the different ganglia, is that the cerebral ganglion, which I keep talking about, which is their version of a brain, that's, guess what? That's the biggest ganglion in a bivalve, which is, I think, is very appropriate and which makes sense because it's the control center. It's not, there's a smaller one which is attached to the the foot, the pedal ganglion, and there's another smaller one which is attached to the gut, which is the visceral ganglion. But the cerebral ganglion, yeah, it's their brain and it's bigger. So, you're going to get, again, a big proportion of those 6 or 7,000 neurons is just in the brain. It's that, and what's it doing? Those neurons are there for a reason. They're taking in sensory stimuli, etc., making decisions, deciding whether to dig or whether this light is or a shadow coming into the light is an indication of danger, etc. And the thing about the severed fingers is that same kind of principle also applies to tumors. I'm sure you've come across the tumor argument, haven't you? I have.
Absolutely. I just have to laugh at that. It's fucking insane.
Yeah,
Kid, we had to
yeah,
argue against that line of reasoning, but I'll let you go into detail
yeah,
explaining why
yeah.
that's so stupid. Like,
Yeah, okay. Yeah, well, I mean, for one thing, it's incredibly unusual for a tumor to contain any neurons. They don't tend to, but very occasionally it can happen. For example, if you've got conjoined twins, I'm talking about human development, of course, or potentially non-human, I suppose. But if you've got a human being who's a conjoined twin and they've developed reasonably okay, hopefully fine, but they've got an undeveloped conjoined twin still attached to them. That twin may not have developed properly at all, and so they could potentially have some neurons in there, maybe even some brain neurons. You know, the beginnings of a brain, but it's nightmarish if you ever look into this. You probably shouldn't look into it. Nobody should. It's horrible. But you know, there's like a single tooth in there, and there's like little bits of body part all sort of mangled up. It's nightmarish. It's horrible. And the thing is, either there won't be any awareness in there because the cerebral ganglia just haven't got going, or the brain has got going in there. There is a functioning brain of sorts, maybe a minimal brain, but it's still acting as a brain. And it's stuck there inside a tumor. Now, if you think about it, that's absolutely something out of hell. If you were a consciousness that was actually stuck inside this tumor, can you imagine? So, and being trapped in there with the type of neuronal constructions which could sustain awareness, and which would make would make it in charge of the tumor. It's the brain of the tumor. That consciousness would be trapped in that terrible existence, and in those incredibly rare circumstances, if it arose, then the kindest thing to do would be to kill the tumor for its own sake, because otherwise you're prolonging this incredibly miserable, nightmarish existence for this poor being who's trapped in there. In the same way that, if a puppy were born with horrific deformities and we're never going to be able to live a proper life, then you should put them to sleep, obviously. But that doesn't mean that it's okay to kill bivalves, because they are living a proper life for a bivalve. They're not a human consciousness trapped inside a tumor. I said humor then. They're not a human consciousness trapped inside a tumor. They're an animal, and they're capable of living an animal life. So let them live their animal life in the same way that you should let a fish live a fish life, or a chicken live a chicken life. And so, yeah, the tumor argument just doesn't have any validity at all when it comes to bivalves, because you've got these other factors coming in, like the welfare of the consciousness itself, if there is a consciousness in there, and indeed the welfare of the being that it's attached to, the healthier twin. And legally, there have been, court cases where it's been decided that you can let the conjoined twin die, the sick dependent one. The parasitic one, you can let them die, etc. It's a very nasty area, but that's the response to that. But the idea that it would be okay to kill a bivalve because a tumor could potentially have neurons in it just doesn't work. I mean, you could apply that same argument, of course, to killing other animals as well, which is another reason why it's a bad argument. Because you could say, well, you shouldn't kill a dog or a cow because it causes suffering and it deprives them of their experience of life, etc. And then somebody could say, oh, well, yes, but what's that experience of life based on? Well, the answer is neurons. So then you can say, well, okay, then, if you could kill a tumor with neurons in, then you could kill a cow with neurons in. You could kill a human being with neurons in, and so it all falls apart as soon as you start extending it. And so if you can't use it against other animals, then you shouldn't be able to use it against bivalves either. It's just not a valid argument. But anyway, I think I've covered the main bases. Would you like to jump in?
Yeah.
Yeah.
I mean, you made a clear case, and I'm absolutely convinced. And in future videos, if I ever do them, or debates that people challenge me, obviously
Right.
from me initiating the challenge, I will immediately bring that up. And hopefully in the description, this future video that me and you are going to agree to post, I'll
Yeah.
link the research, to if anybody wants to, explore in detail what you're saying to, validify, what you're saying. But yeah, I'm absolutely
Yeah.
convinced, and
Yeah.
I appreciate you going into
Yeah.
detail.
No, that's fine. One thing I forgot to mention, which is really important, maybe the most important thing of all, is, and I know that you're familiar with this, but we have to think about what the moral consequences are if we behave as if bivalves are non-sentient, and then we find out that they are.
Yeah.
Just people used to think that fish are non-sentient, but now we know that they are. I mean, bivalves are typically killed by being steamed to death. And if you steam a creature to death or boil a creature to death, a sentient creature to death, then that is truly horrific. You're torturing them to death. You're torturing them to death, and that's in huge numbers because they're so small, relatively speaking. And that means that lots of them get killed per amount of food. So, whilst my main point is that they are sentient, my subsidiary point is that even if you think there's only a 1 in 10 chance or 1 in 50 chance or whatever that they're sentient, why take that chance? Why would you gamble on the possibility that you are inflicting a torturous death on a sentient being? So, that's the precautionary principle, which a lot of scientists talk about. It's very important, the benefit of the doubt principle. You don't have to have complete certainty. You just have to have reasonable grounds. It can still be a minority chance. It could be 1 chance in 10, 1 chance in 50.
Like, we can't be 100% certain that anything is not what it is, but the issue is, okay, we apply that position in a logical consistency test, look at what the conclusion it leads to, and you could come to an absurd come to find out that the conclusion is absolutely absurd. It will lead to holocaust of all of us, all of us sentient
Yeah,
beings. It's absolutely.
yeah. And the biology community, I have to say, hasn't really helped with a lot of this because they really dragged their feet about fish sentience, even though the evidence was all there. They were very slow about that. The sentience of lobsters, as I said, has only been sort of generally recognised or officially recognised since around 2021. So they're very, very behind. They've always been behind the curve in terms of recognising sentience, and that's partly because biologists, if you think about it, they tend to be people who are happy using animals, for research, etc. They're people who have been brought up in school doing dissection, and they didn't mind doing that, and they go to university and they do a lot more dissection, sometimes vivisection. As a demographic, they are disposed to be against the idea of animal rights, against the idea of animal sentience.
Yeah.
On the whole, and they're over cautious about using the word sentience. So what I always try to remember is not to take the biologist's opinion statements too seriously, but to look at the actual facts which they tend to come up with. So they do these studies, which are very useful, and they reveal interesting data. And you can look at that, you can look at the anatomy, etc. And then once you combine that, especially with behavioral stuff, which we've only just touched on briefly, how bivalves behave. You put that together, you can just use common sense to see what the answer is.
Exactly.
So yeah, biological data is very important, but not necessarily the opinions of individual biologists, which, as we've seen with fish, can very often be wide of the mark. But yeah, the point I was going to just bring up is this concept I've come across, and it seems to come ultimately from Tom Regan, who was an animal rights philosopher. And I've heard bits of what he's said, and on the whole, he seems to be good. But one of the things he put forward, one of the theories he puts forward, wasn't very good. It wasn't very valid, and it's been misused since then. So it's got even worse. And that is the idea that some creatures lead a quote unquote trivial existence.
Completely subjective.
Yeah, it is subjective. But the idea seems to be that, unless an animal is living some kind of complex life in a complex social structure, etc., then they don't deserve moral consideration. And
oh my goodness.
Yeah.
So
and
exactly
I think
like
that's
a Nazi.
Yeah. Well, yeah, exactly. Exactly. I mean, that's the obvious implication of that, because, what did the Nazis do with people who have mental handicaps, who could only live a very simple existence, who, didn't have complexities necessarily in the way they express themselves? Maybe some of them couldn't use language. But does that mean it was okay to kill people? Or, of course it wouldn't. We wouldn't do that to human beings. And so if we wouldn't do that to human beings, then why should we do it to non-human beings? It's simply wrong to base our consideration of the lives and the welfare of other beings on how intelligent they are. Intelligence doesn't have anything to do with sentience. It doesn't have anything to do with awareness. A chess champion, might have an IQ of 170.
Mm-hmm.
Uh,
Doesn't make him
meanwhile,
more sentient than
yeah,
anybody who's significantly less intelligent.
no, exactly. It's a completely different measure,
Yeah.
completely different set of criteria. And the same way, somebody who's a very good artist, they might have a far more complex brain than I've got, a complex mind, but that doesn't mean that I can't suffer.
Yeah, exactly.
And
It's a
so
psychopathic point of view, in my opinion. Like, it's a completely selfish, unempathetic point of view, to the extent it's like, okay, well, you don't matter because you lack being me, basically.
yeah, you lack being me. Wow, that is a hell of an expression. Yeah, they lack being me. Wow. Yeah, that is it. That is it. There's one idea that Eisel Mazard came up with, which I thought was very interesting. And it was to do with how these days, because so much of us have seen science fiction, we tend to think. Or in fact, I've written out what he said. I put out I printed out the actual text, the original subtitle text. And what he said is, sentience is about feeling. It's not about dreaming. It's not about planning for the future. It's not about complex philosophical cognition. Many people are misled as to what sentience is, because most of the debates we hear about it in modern Western culture growing up are from science fiction, where there's the emergence of sentience amongst computers or robots. And we have this fantasy that computers develop more and more sophisticated capabilities in terms of memory and apparent intelligence. And then at some point, when they're incredibly advanced, they cross over a threshold from mimicking human intelligence into being genuinely sentient. Science fiction puts in people's minds the expectation that when we are debating animal sentience, we look at a dog as if it were a computer or a very advanced robot, that the dog mimics human emotions and mimics human reason, and only at some higher level could they become sentient. And this is completely false. The reason why computers and robots are thought of this way and not animals is precisely because sentience is about feeling, it's about response to stimuli. So I think that's very interesting, because people sort of make up their own definitions of sentience. Sentience means consciousness, it means awareness, it means being able to experience the world, of course. But people add on their own things. They add on intelligence level. which is irrelevant. They add on self-awareness. Well, self-awareness isn't necessary
Yeah,
in terms of sentience.
that's just a like that's basically an IQ
Yeah,
test. Basically, it's not a yeah.
yeah, yeah,
You
yeah.
can't deductively prove whether somebody is feeling when by lacking a certain level of intelligence.
No, no, exactly. And it's a particular way of thinking as well. Self-awareness. For example, there's a thing called the mirror test. I don't know if you've come across that, but
Absolutely.
yeah, you have. Okay. And obviously, as you know, then it's when you can stick a, a coloured dye or something on the forehead of an animal, and then you
Hmm.
show them a mirror, and then, as you know, some animals see that in the reflection and then wipe it off their forehead, and some don't. And dogs don't pass the mirror test, and yet we all know
Hmm.
how intelligent dogs are. We
Hmm.
know how empathetic they can be, how emotionally complex. You know, they've got all these different levels to them. And they can certainly suffer, which is what it comes down to, and they can experience life, as we know. They're inside a dog. We're inside a human being. We're all alive. We're all conscious. And yet they don't have that self-awareness thing. So the self-awareness thing is just, again, it's like the skull having to be around a brain. It's just another way for human beings to load the dice so that
Exactly.
we win the game.
I'm
We,
sure there's I'm sure there's human babies that can't pass the mirror test.
oh yeah, yeah, absolutely, absolutely.
Hmm.
You know, so that means that a 1 or a 2-year-old child. What does that mean? It's okay to kill them? Of course it isn't.
Of course, exactly.
You know, it's just ultimately it's. I think that ultimately moral consideration for other beings comes down to common sense, and that's one of the things which I value about your channel and the things that you've said is that you keep things clear. You know, there's a clarity about the stuff that you've said, which I think is great.
Appreciate it. I'm always willing to learn. I'm willing to be challenged. I obviously I have some personal issues. I potentially may have some mishaps.
Yeah,
I'm potentially a sociopath, but I'm not manipulative. I lack certain sociopathic traits. I'm very. I can be
yeah,
honest about this. I'm very impulsive. I'm very reactive. So like if something obviously if
right,
something's personal towards me, yeah, I'm gonna take
yeah,
offense. I'm gonna attack that. Me
yeah,
being
yeah,
ignored by people, me initiating trying to have honest conversations. That's clearly a personal attack against me. When especially they're willing to
yeah,
debate other people, who clearly have actual dumb positions. In this case, I'll refrain from their personal
yeah,
stuff, but yeah, I just want to give some, I just want to give some context
yeah,
to
yeah.
where I'm standing, where I'm coming from. Um,
Well, you don't come across as a sociopath to me.
I appreciate it. I
or,
appreciate it.
or if you are a sociopath, then you're a sociopath who's easy to chat with. So thank you, and
I
thank you for
appreciate it.
inviting me on. Thank you for inviting me on. I've really enjoyed it.
I appreciate it.